All right, today we're going to talk about looking at circles in the coordinate plane, how to graph circles, how to look at a circle on a graph and write the equation, and how to turn things into the standard form equation of a circle. So first off, this is the standard form for the equation of a circle. The x and the y are always going to be there. We can plug in x values and y values to see if points are on the circle. The key part here is going to be the minus h, minus k, and r squared. So when you're looking at this, it's important to recognize that it's always minus your h value, minus your k value, and then your radius, your r value squared. That h value that is right there and that k value that is right there tells you your center point of the circle. Now that can be a plus if it's a negative h value, but we identify this number, that's our h value for the center of the circle. We identify this value, that is our k value for the center of the circle. And then whatever the square root of this number is, because when we square root r squared, we get the radius. So first off, number 1a, if we're remembering the formula first, then we're just going to substitute in. So first off, we need to find the center of the circle. And so if I were to look at the point that is directly in the center of the circle, we're talking about that point right there. First off, identify that point as negative 5, comma 4. So that means that negative 5 has to go in for my h, which is going to make my equation go to x minus negative 5 squared plus y minus, and then my k value, 4 squared, equals whatever my radius is. And remember, the radius of a circle is the distance from any point on the circle to the center. So just find the easiest one. We're going to go 1, 2, 3, 4 units, and we can verify it this way as well. 1, 2, 3, 4 units. So the radius is 4. So that means my r value has to be 4. So it is 4 squared. And then we can simplify that because the minus the negative 5. We are going to get x plus 5 stays as y minus 4, and then 4 squared is 16. If it is centered at the origin, then we need to remember that that is 0, 0. That one's always going to be a little easier because if we recall the formula then, I always start just by writing the formula. That means that's minus 0, minus 0. So that part's not even going to need to be a factor. It's just going to be x squared plus y squared. And then that's going to equal 3.5 squared. You can turn that into a fraction or keep that as a decimal, either way. But you would get 12.25. So another way to look at it is talking about a point that is on the circle. So if I was to think about this in the coordinate plane, I have 1, 2, 3, 4, comma 1 is a point that is on the circle. And then I have 1, comma 4 as the center of the circle. So my circle is going to look something like that. That's a terrible circle, but you get the idea. Here's the center. There's a point on the circle. The reason why it's giving you this information is the fact that this distance is the radius. So the distance between these 2 points is going to be the radius, and we've already done the distance formula. So plugging in the distance formula, my x value is 4 minus 1 squared, plus the difference of my y value is 1 minus 4 squared. I'm going to get 3 squared plus negative 3 squared, which is going to be the square root of 18. So then, plugging this into my standard equation of the circle. Remember the equation of the circle. So using the center point of 1, 4, so it's going to be x minus 1 squared, and then 4, so y minus 4 squared. And then when you have the square root, we didn't even have to simplify this because it's going to be radius squared, so square root of 18 squared is just going to be 18. The last type of question we're going to go over is recalling a big Algebra 2 concept called completing the square. If we notice, this is not in our standard equation of a circle form. So we want to make this equation for number 3 look something like this. So first off, what you're going to do is group your x's together. And then leave an opening for the process of completing the square. Group your y's together, leave an opening to complete the square. And then move that negative 6 to the other side. So this is something that you're going to have to do every single time. So if you just set it up like this first, it'll make things a lot easier. So when we are factoring for a completing the square, we're going to take half of negative 2. We're going to get x minus 1 squared. If we were to think about what x minus 1 squared is, if I was to FOIL that out, I would get x squared minus x plus 1, which is x squared minus 2x plus 1. So if I had x squared minus 2x plus 1, it would factor to x minus 1 squared. So I need a 1 in this spot in order for it to factor to x minus 1 squared. That's the number I need to complete the perfect square of x minus 1. But in order to do this mathematically, I need to put a 1 on the other side. I can add a 1 to the left side as long as I add a 1 to the right side. For the second one, I'm going to take half of 6, which is 3. When I square 3, I would need a 9 over there in order to complete the square. But remember, if I add a 9 on the left side of the equation, the equal sign, then I need to add a 9 to the right. So now, on my right side, I have a total of 16. This actually then tells me everything I need to know because the center of my circle is 1, negative 3. And then my radius is the square root of 16, which is 4. Go ahead and pause the video and then practice the last 3 questions, which are very similar to the first 3. So for number 4, we should get that. X plus 4 squared plus y squared equals 2.25. And then using the distance formula again for number 5, very similar to number 2, we would get x squared plus y minus 2 squared equals 13. And I'm going to go over number 6 in a little bit more depth, remembering what we do here. We have to group our x's together, leave a spot, group our y's together, leave a spot, move our plus 1 to the other side, which makes it a negative 1. And then add our spots over there. So in order to complete this square, half of negative 4 is going to be negative 2. So this is going to be x minus 2 squared. In order to complete that, though, I need to add a 4 to both sides. For the second one, half of 2 is 1. In order to do that, I need to add a 1 to both sides, which gives me a negative 1 plus 4 is 4. So this tells me that the center is negative 2. I'm sorry, the opposite of this, which is 2 and negative 1. And then my radius is the square root of 4, which is 2. And then we could graph that circle. The completing the square is definitely the more challenging portion of this notes. But that concludes our section on circles.